designing, so you have to check if any of your structural member has failed. So you can see that this beam is red in color, so chances are that this beam has failed. So just go to design and click on concrete frame design and click on verify all members passed. You can see that 4 concrete frames failed the design check. So I think these 4 members have failed. So here the beams of a single floor failed. So sometimes what might happen is that if your structure is very huge, in that situation beams or columns at different locations might fail. So what you have to do, you just select them. Okay, so I have selected the beam. So now we'll just modify the size of these beams. Okay, before that, just assign these beams to a group so that we can know which beams have failed, right? So for that, go to assign and click on assign objects to group and click on add group. So the name is group 1, so we'll just name it as fairly failed BAMS beams. Okay, not beams, and we just click on OK. So these members have been assigned to the groups. If you want to see why that beam failed, again click on design, click on concrete frame design and click on display design info and click on OK. So if you left click on this beam and right click over here, just click on summary, so you can get the summary sheet of your beam design. Okay, so the label is story 1, beam ID is B2 and unique name is 6 and beam ID is beam. Okay, so combination is decon 10 and okay, so length and other things. Section properties, so breadth is 230, depth is 350 and other things. Okay, so just go to the bottom. Over here you can see that shear stress due to shear force and torsion together exceeds the maximum allowed. So it means that our beam has failed in shear, so it is not able to carry all the shear force that due to the load. Okay, so what now we'll do is that we'll increase the size of this beam. Okay, so for that, just